I'm recording.
Yeah. So I was going to say, since we have a smaller group, I think it probably would make sense that you can have a conversation. I think that could be a good start. I also have some slides, like I can talk about some stuff with Rust as well, but maybe because I lecture for 3 hours at a time, I can talk and I can do demos. I can do anything you want. But maybe just to start off with, let me just give you the pitch of why I think Rust is very interesting. So I'll talk a little bit about my background. So my background is that I started Python in 2000. I was working at Caltech as an IT person, and I met a lot of Python people there. And even though I was kind of a jock a lot of my life, and even wanted to be a pro athlete at one point, I when I went to Caltech and I played ultimate frisbee with people, I felt like this other kind of peer pressure, which was, hey, you don't know Python, like what's wrong with you? Like Caltech is a weird place. Like you feel very pressured, like, oh man, I felt insecure. And so I taught myself Python. And so I really have, even though I now teach at Duke, and I've taught at Northwestern, so I've taught at some pretty prestigious schools, I've taught myself to program from the very beginning. And Python really has served me well. I've done all kinds of things with Python. I worked in the film industry, did a lot of distributed computing in Python, like worked for Disney Feature Animation, Sony ImageWorks. I worked in New Zealand, Atlanta, Georgia, all Python kind of stuff. And there's a lot to like about Python. I've written multiple books on Python. I think there's some things, though, that are worth considering in terms of Rust versus Python. So here are the things that I think are worth considering. One of them is that there is a lot of demand for data engineering and machine learning engineering. We see it's just exploding, right? Like that's one of the hotter areas. And in particular with data engineering and machine learning engineering, performance really does matter. I mean, if you're doing big data pipelines, you're building asynchronous distributed systems, the performance can really make a difference. And there's a lot of stories now of different libraries getting written into Rust. In fact, there's Delta Lake Rust, which is a really cool library. There's the Polars, which is a competitor to Pandas, which is written in Rust. There's just so many different Rust-based things being written, and part of it is that if you can reduce the memory, if you can reduce the CPU, you could potentially save 40 or 100 times, right? The performance, I'm sorry, the cost profile for an application. So I think that's why, depending on what it is you're doing, you should at least consider, if I'm going to run something at scale over and over and over and over again, millions of times per month, why wouldn't I consider doing something like Rust? Now, let's talk about some of the scary things about Rust. So the first thing I think that someone might consider is that, especially someone like me who's programmed over 20 years with Python, someone might go, this is ridiculous. Like, how dare you say that we should program in a hard language like this? Because in many ways, Python, you have it easy, right? Like Python is very simple. You just look at it, you write some code. I mean, if you want to write a Lambda function in Python, it's trivial, right? Like you just take 5 lines of code, and you have a distributed system that you built, and you can leverage AWS to do concurrency and all this really cool stuff. But I think the issue is that there's, in addition to the performance, there are other factors at play here that may also be something to consider. And in terms of the pair programming tools, that I recently had the CEO of GitHub give a guest lecture for my class, which was pretty cool. And we had a really good conversation over a couple hours. And one of the things that he said was that 80% of code that is being written, that's checked in now, if someone's using Copilot, is from Copilot. So if that's true, and let's just say it stays at 80%, we know that the reason people liked Python, which was syntax is great and is built for humans, and I mean, those are legitimate reasons, that may not actually exist anymore. And so if you're going to build things in a different way where you don't care as much about the syntax because the syntax is being taken care of for you, then why wouldn't you pick the hardest language you could possibly pick? Right? The one, the one that's the most powerful. Like if someone says, hey, you can drive a like a Yugo, or you can drive a Porsche, or F1, car or something, I think many people would say, well, I can't afford the other one, it's too expensive. But what if you could? What if someone gave you a $250,000 car and just said, hey, here we go, here's the keys for it? I think that's what the pair programming does, is it opens up this other layer of programming that isn't really available, I think, to many people without the pair programming tool. I'll be honest, I don't know if I didn't have early access to all those tools, because I've been involved with GitHub for a while. I don't know if I would have been as gung-ho on Rust. I'm almost certain I would be a lot slower on transitioning to Rust. So I think that's a second pillar in Rust, is that if you think you should be doing things the way you've always been doing things with this revolution that's happening with AI, I think you should be very concerned, because how could it possibly be that this amazing tool that does summarization, can write code for you, fix bugs, how is it that that's available and you're still doing the exact same thing you've been doing before? That seems like a very bad strategy for your career. So those are really the two drivers, I think, are the fact that there are some severe limitations with Python in terms of performance for the fields that I'm personally interested in. And then two, the pair programming tools are good enough and getting better. And I think the combination, it really is pretty amazing. Now, there's a third kind of pillar here, which is that there are things that you can do besides just performance and memory usage, which which are amazing, and security. Like Rust has an amazing security and safety, and one of them is binary deployment. And binary deployment is one of those things that kind of sounds like, oh, who cares, binary deployment? It's kind of a big deal, because with Python, if you're building command line tools, there is no way to distribute command line tools that's universal or common. In fact, one of the problems in Python, I guess it kind of goes into the fourth pillar I was going to talk about, but basically, just like you've seen some cities in the United States go into decline, like Detroit, San Francisco may be one of the cities goes into decline. A lot of times they go into decline and they have incredible revenue. Like San Francisco is a perfect example. As a former resident, the amount of revenue that San Francisco has, and the money, is just shocking how much money that city has. But what happened? Like, why? And I think part of it is that when the right conditions don't exist inside of an entity, there's not enough pressure, like things get out of whack and everybody just goes to your location or they use your tool. It lets people let their guard down. There has to be enough of a balance where the right things are getting built. And I think Python really dropped the ball on two things. And one of the things that they dropped the ball on is the global interpreter lock. They've tried to fix it for decades. And in fact, the original maintainer, Guido, who I actually do know and I've met many times in person, has basically gaslit people. I'm not trying to be mean to him. I mean, he's way more talented than I am and way more successful than I am, but he did gaslight people for a long time and said that concurrency doesn't matter in terms of the way concurrency matters with all other languages, and said that, oh, you can just use processes.
No, I
No,
wonder. I wonder if you could explain to people what the global concurrency lock is, because not everyone may know.
yeah. So the issue here with Python is that, and again, I'm not actually trashing the author of Python. Like I said, he's smarter than me, like more talented than me, and more successful than me. I just happen to have known him, had some conversations. You can be all those things and still be wrong about one of 100 things. So the issue is that when they first wrote Python back in, I think he wrote it in like 90 or something like that. I remember 1990. I'm old enough to remember. Some of us know, right? I was actually uh, just starting high school. I graduated in 93. There was no World Wide Web. We had like CompuServe. I would go into a BBS, and there was a guy in my neighborhood where we had like a 2400 baud modem or something like that, or 5600. I forgot what it was. It's like beep 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 beep, and there's like, and I would play Legend of the Red Dragon. It was like the text would come down the screen. Like that was the world that they built Python in. The concept of, the World Wide Web didn't exist, the internet in the way it does now. There was no concept of multi-core machines. Like it wasn't even something that, was on people's minds. And so when the author of Python first created it, it wasn't something he was thinking about. Oh, we got to make like multi-core machines and all this stuff. He's thinking, and to his credit, was probably the right choice, which is, let's make this really simple. So if we don't have true threads like Java does or C#, then people won't get in trouble, right? Like if you don't have race conditions, then people won't get in trouble. So let's just not make them. And so I think that was the original design decision that may have been the right choice initially, which is that you can't have true threads. But now also in that period of time, there was Moore's law, and Moore's law was essentially that, every 18 months or so, every 12, 18 months, computers would get faster. I remember this. Like it was amazing. Like you were like, wow, I just bought a computer and it's like worthless. Now I get another computer. I mean, it was really kind of an exciting time for computers, but there was no like multi-core machines. I mean, this was not even something to think about. But now we know Moore's law is actually gone. And in fact, it's completely plateaued, and for quite some time. I mean, and in fact, people are getting maybe 1-2%, 3%, clock speed increases, and so you have to actually use multi-core technology. And so now we get into a situation with a global interpreter lock, where because threads are only available on one core, if you're using cloud computing, you have a significant problem to deal with. And the significant problem is, how do I actually use the other 3 cores that came with my virtual machine? Do I just let them stay idle? Because you're wasting a lot of money by, using a machine that's bigger than the one that you need. And then if we go back to what some people have said, which is wrong advice, which is, oh, you just spawn the multiprocessing module and create a process pool, and then you just throw things to the process pool. Incorrect, because Python already is one of the worst languages at memory. And so processes have way more overhead than threads. In fact, they take seconds to spawn as well. And so depending on what it is you're doing, you're massively using the wrong technology to do parallelization. And so I think that's the thing for cloud computing. It really can cause some significant issues, and who knows if Python will ever fix it. But for decades, at least a decade more, really there was like a gaslighting of people, where they would, gaslighting is kind of an overused word, but this is actually true, is that they'd said, oh, you don't need threads, true threads. Like, no, you do need true threads. You do need true threads, because we look at languages like Rust, Java, etc., C#, and you can just do something that uses all the cores and all the memory. I mean, it's very efficient, and threads launch in milliseconds. So I think that's one of the core issues with the global interpreter lock is not being able to use threads to parallelize your workload is very significant. And where Brian and I were talking about this is it comes into play with the things like serverless, is that, you know, depending on what it is you're doing, there could be a significant penalty for a stateless type application. Because if you just want to execute something that uses all the cores and you are forced to use processes, and you're actually billed by how long it took, and it takes 2 or 3 seconds to spawn a process pool, ouch, right? Because every time you invoke that Lambda, it's going to take a bunch. You're just paying for stuff you don't need. In addition, you're paying for memory you don't need. If you use a language that actually can use threads to distribute the work, you don't have to do anything. Like in the case of Rust, they have a library called Rayon, and there's almost nothing to do. You just say, like, make this parallel, and then it uses all the cores, and it's extremely efficient and very low memory. So that's essentially the issue with the global interpreter lock. Does anybody have any questions about the GIL?
Well, I know not a question. Well, does someone actually have a question about Gil? Go ahead.
I was just going to add something, actually. I posted in the chat, and I agree, actually, that, yeah, Python, it was built like to optimize being a nice language to code in, right? Where Rust, it's kind of the name of it. It's like comes from just how your server should be running your Rust code so long that it like turns rusty, right? Because you won't need to rewrite it again after that. It's just as efficient as you can get. But this article is interesting because the guy is saying, like, at work they have a whole team of data scientists and people who like coding in Python, but they still wanted to make it more efficient as Rust maybe. And so he kind of explains how they offload parts of it. The title of the article is Making the Python Code 100 times faster with Rust, right? So they somehow were able to use them together. So it's not necessarily all or nothing. Also with like AI type things, right? Maybe you could create your trained model in Rust and then load it into a Jupyter notebook in Python, or load it into your browser. Maybe.
Yeah, I mean, I think there are some people that are mixing Rust and Python, and that potentially could be a good solution. My take is a little more radical in that is that if you have these pair programming tools available and syntax doesn't matter, which I think we are at the point where syntax doesn't matter,
Well,
why do you care about syntax?
I mean, have you actually used Copilot like to fix bugs and things like that? Because to me, I don't know, I haven't found it all that like miraculously helpful. You know, the hard part wasn't typing, it's actually getting all the pieces to fit correctly together, right? So you still need to have that knowledge, even if you're using Copilot or something else.
Yeah, so I actually have extensive. I've for the last almost, let's see, 9 months. I'd say 9 months or so. I've been programming very heavily in Rust, and I think what people misunderstand about tools like Copilot is it's not a panacea. Like, it's not like you just wake up one day and you just throw the code into like Copilot and it just fixes everything. In fact, it's a little bit more like a forklift versus a human, right? Where if a human has actually dug a ditch and built a house and, you know, done different things with like a forklift or like a tractor, they have a deep understanding of, you know, construction. And if they got into a tractor or forklift, they're going to be very different in that tractor or forklift than someone who's just was working at McDonald's. And they're like, okay, here's a forklift or here's a tractor. And I think that's part of the issue with the AI pair programming tools is if you have 20 years experience in Python, like, I mean, I can build entire companies in Python, and I have built entire companies in Python where I've written all the code myself in, you know, a couple months, and that you can translate that experience into Rust, but you just have a more powerful tool. It doesn't mean that it's magic and that some of the things that would have to do with programming go away. You still have to understand it, but it just makes you more impactful. So I think that's part of the issue as well, is that if you are able to go to a more difficult language like Rust, you can address what we're just talking about, which is the global interpreter lock. You can build multi-threaded code. And the other one that I think isn't talked about enough is that Python has some pretty bad problems in terms of reliability. And one of the problems is that if you don't use DevOps best practices to write Python, you're really getting yourself in big trouble, because there is no compiler. And so whenever I write Python code, I'm pretty religious about it. So I'll use continuous integration, linting, formatting, testing. I'll do all this stuff to kind of effectively counteract the fact that it's easy to write low quality code in Python. But with Rust, it's a little bit different because the compiler is so intense and so angry. I mean, the compiler is very, very strict that in a sense, it works extremely well with a pair programming tool that can hallucinate, because if you do accidentally put something in there that's bad, the compiler says, bye. Like, no, you can't do that. So if you hallucinate with a language like Python, not good. You better have really good linting. You better have really good unit testing. And so I think that's the other, maybe emerging thing that we're going to see, is that it really is going to be important to have amazing DevOps methodology and really good compilers and linters. And I even have noticed the difference between Go and Rust is that Go is pretty cool too. Like Go, you can build binaries and distribute them. But the difference between writing a command line tool in Go and Rust is like Go will just let you write bad code. I mean, I was just doing this 2 days ago. I was writing something in Go and I was like, whoa, this code sucks. Like, it was not bad. I was writing bad Go code and it compiled. I was like, how did this compile? Like this code is broken. It's like, oh, Go lets you compile broken code. Okay, well, there we go.
So Noah, I think this brings us to an interesting point, in that I remember I've been through the writing C++ as C and then writing Java as C++, and it comes down to, and there's been the whole thing about, hey, you should write Pythonic Python. So aside from the syntax, and stipulate for a minute that Copilot or Code Whisperer or something like that, or ChatGPT can help you with the syntax. I want to get a sense of the feel of Rust, and so I wonder. I would love to see some Rust if you can show us some, because I want to see, what does this feel like? Because my background's in linguistics, and so the language that I work in colors what I think about, and so I want to, what would Rust thinking feel like? So, I'm seeing some nods, so I think people want to see some Rust.
Okay. So let's do some Rust. So let me do this. The latest thing that I wrote that is maybe the coolest thing that I wrote recently in Rust is a pre-trained model that uses PyTorch pre-trained model that works with something called Distroless. Are some of you familiar with Distroless? So I'll just show you the repo and we'll just talk through it. So this is actually something that, and you might have to let me share, but I don't.
I know I've turned that on.
You got it. Okay, cool. Okay. So here's a repo that is called Rusty Deploy. And this is some of the latest stuff that I've actually been working on. You can see I was working on it a couple weeks ago. And the goal of this project is to focus only on building machine learning operations workflows in Rust. And I do think this demonstrates exactly why you should use Rust, is Rust for MLOps. And some of the things that I'm planning to do include being able to use Distroless to serve out a microservice that has a pre-trained model. And I did that. So that one I have solved, and I'll show you it. And then another one is that Hugging Face distro list. So I want to take the Hugging Face models that I have and get that working. I can also show you, actually, I have a bunch of Hugging Face stuff that isn't deployable but is runnable. So I have a lot of AI ML stuff in Rust that I can show as well. But just to start with, this is probably a good starting point. The other thing that I want to do, which I think is so foreign to people doing ML with Python, is statically link Onyx, which is a portable runtime, to a Rust binary, statically link PyTorch to a Rust binary, and statically link Hugging Face to a Rust binary. So maybe before I show the code, we can just for a second ask, does anybody know what any of these are? Or should I talk about them a little bit? So basically, the idea here is that one of the amazing things that you could do with Rust that I haven't done yet, but I've seen some people kind of do, is that you can actually give someone a command line tool that has a model inside of it. And that's amazing, because think about what are the things that you could do with that? Like Linux, the entire operating system is a bunch of command line tools. What if all those command line tools had machine learning models in them? We can do this, right? And so that's one of the things I'm working on now, is to operationalize this a little bit better. And Onyx is just a portable runtime for models where you can take a model in PyTorch, TensorFlow, MXNet, all these other formats, and convert it to like a universal format. That's one of the ones. And then the other one is to actually put PyTorch and a pre-trained model inside of a binary. So why would you want to do this? Well, you could just give somebody a summarization tool, or you could give someone a computer vision tool, or you could give them a chat bot, or you could build anything you want. And there's nothing to do. There's no like installation. There's no infrastructure as code. There's literally nothing. Here's your binary, run it. So I think that's amazing. And that's some of the stuff I'm cooking up. So that's this repo. Let's get into the code now. So I personally use Codespaces to code. And I like Codespaces because I can set up a reproducible environment to code in. Let me show you a little bit about some of the things that I've got set up here. So one of them is, if you go to this and you say new with options, you actually can go down here and you can open up 16 core machines with like tons of RAM, or you can open up a super beefy GPU machine with 100 gigs of RAM, which, depending on what you're doing, it really is awesome. I'm going to use the 16 core one because that's what I've been mostly focused on, which is this one. The other thing I'm going to point out, though, is that inside of here, we have the configuration for this environment. So what happens is that there's a Docker file that installs some things that I need, and it's based on the Rust image here. And then I also have a dev container.json, which has some configuration inside. So like if I wanted to install CUDA, for example, or I wanted to do some kind of extensions, I can put those all in there. What's nice about this is that anybody in my team or an open source person, you just run this. You can just run your own code space, and the entire environment is all set up for you. So what that means is that I can just launch this button and it'll work. One other thing that I set up is this, which is if you go to Codespaces, this code and automation tool, and you go here, that I have something called pre-build set up. And what this means is if you set up pre-build and just click through the buttons or whatever, it means that every time I make a change to this environment, it already has the full image baked and ready to go. So it launches in just a few seconds. And so that's what's going to happen now is if I go over here and I say to code, and we just click on this button, it's going to launch my code space. And it's just boom, instant, right? And then if I ever needed to make a configuration change, I would actually make the changes inside of most likely Docker. I would tweak some things inside of it. And then when I check it in, the code space would get built programmatically. And then next time I wanted to launch it, it would just launch. Or if somebody else on my team wanted to use it, they could do the same thing. So this is kind of like if anyone's ever used Cloud, I'm assuming maybe at least one of you has used Cloud9. Is that correct? You've used Cloud9, Brian, right?
A little bit, not all that much.
So this is like Cloud9, but on steroids, basically, because it's reproducible and shareable. You can share your configuration. So there's no installation necessary. Like there's nothing. You just start writing code, which if it depending on what you're doing, the setup can be really extensive for something like MLOps. So now that we got this working, and I want to do Rust, I would just type in Rust C, right? Oh, we see we got the Rust compiler, and I can do -- version. But the part that I set up was a project called RTorch dist, and if we take a look at it, we can see some of the layout for this project. So the first thing that we've got here is we have a main, which if you're familiar with any web framework of any kind, that there's typically something that invokes it. Like for example, Flask or Fast API. This doesn't look that much different, right? They have some kind of a thing where they hook in all the routes. That's all the main does. A few things that are different here is that this is actually by default async. I'm using a web framework called Actix Web here, but these are the different routes that I've set up. So I've set up an index route. I've set up a check image prediction route. I've set up a check image upload route, and I've set up a check PyTorch route. So for me, when I'm prototyping like a new technology, especially something that is very tricky, that there's no documentation on the internet about, what I like to do is I like to set up a functional route that essentially does each of the components. So I want to upload an image. Okay, let's just make sure that I can do that. I want to make sure that PyTorch is installed, because PyTorch is notoriously tricky for even Python, any language. PyTorch is very complex to set up. I want to just invoke an endpoint that verifies that PyTorch works. And I want to separately break those steps down. And I also want to do an image prediction with a pre-trained model, so that when I finally build my service, which would be my microservice that's going to do computer vision, that it's pretty easy to set up, right? Because I've already broken the piece down into other pieces. So I think that's an important thing to think about when you're building like bleeding edge technology, is are you breaking the problem into really teeny pieces? Because if you just try to get like a computer vision model working and there's no documentation on the internet, yeah, have fun, right? I mean, especially in a new language like this. So I broke them up into pieces. So now if we look at the routes, you can see here that each of the routes just corresponds to one of the things I'm doing. So in this case, this is, check the image prediction. This goes through and it runs an image prediction. I have another one that verifies that PyTorch itself is even working. Now, this might be a good one to just take a look at, is that you can see here, it's just a function, right? There's nothing too tricky about it that is that scary if you're a Python programmer, other than a couple things I'll point out. Like this is the route dispatch. So if you're used to PyTorch, or you're used to, Flask or Fast API, this is identical, right? Check PyTorch CPU. It's just a dispatch. And then this async means that this function is asynchronous. And also the name of the function is just fn, the syntax. And then this is the actual name of this function. So in this case, it actually doesn't take anything. There's no input, because it's just like a self-check function. And you can see here that I have an explicit return. In this case, I return an HTTP response, which has inside of it embedded a potential error message if an error occurs. And in this case, I make an instance of let tensor size, and I give it a string, and I say let message, I give it a string. And then if everything was successful, I return back the message that says PyTorch was successful. So it's not that much different than Python code, other than that there's explicit typing, and that you have to be very careful sometimes, in that it makes you be very safe about how you write your code. Like you can't just use a variable and then like instantiate a variable and not use it, for example. And also they have this concept of borrowing as well. You have to be explicit. Like if you use something, you have to actually borrow it as well. So there's like all these kind of safety mechanisms built into it. So these are the routes. And then in terms of the logic, this is where I just put all of the stuff that does work. So in this case, I have a struct that has some probabilities and classes, and all a vector is basically like a Python list, right? And so this is just a list of strings. And then this thing is a save file function right here. And then I have the self-check predict function. So that's why the other route was smaller, is I did all the heavy lifting, inside of here. And then I have,
no,
yeah,
I wonder if you could go
sure.
just a little bit slower. Maybe I'm the dummy here, but it's like, okay, I'm just trying to sort of walk my way through some of the code. Just,
This is a little bit of a less friendly code to walk, step by step through. I can show you. Let me just run this, and then I'll show you something that's more like kind of like walk through friendly, because this has got a lot of moving pieces to it.
Sure.
But all we'll do next is I'll just show you this. I have a make file. I like to use make files, and I put all of the things that I do inside of it. So typically in a Rust project, what I do is if I cd into this, for example, I just say make lint, and all lint, and I do the same thing with Python too. I just say cargo clippy quiet, and it just goes through and it lints the code to make sure that everything's okay. The nice thing about the linter in Rust is that if it lints or if it compiles, it's probably going to work, right? And so that's one of the things that you do. If you want to build it, you can also do parallel builds, which is pretty cool. So for example, if I type in cargo build -j, I can say spawn 16 different build processes, and actually it will in parallel compile the code using a really big machine. So like if you had, I don't know, a Threadripper or something, you could actually use the entire box, which is pretty cool. And once you've got it built, that's all, you're essentially ready to go. You can do a run. In this case, the run will run it. All I do here is I just set up some logging. So I tell it what log levels I want, and I set a backtrace in case there's some kind of error. I can look at the trace back, and from here I just do this. I just say make run, and it goes through and it runs my code, and it does a couple little final touches here. But I'll show you the code running like this first, and then I'll also show you that I have something that's a smoke test. And this is what I like to do if I'm building a microservice, is I like to build like, several different curl commands that just invoke all of the main entry points, right? I'm sure some of you probably do this with other microservices. So, call the index, call the image prediction function. In this case, I even upload an image and have it do a prediction. And then I even download an image and have it do a prediction right here. So that's how I like to test the functionality of the application as well, as I just run this smoke test. So if we let this thing do its final steps here to build, should take just a second. All we would have to do next, there we go. So it's running, and then with this environment, it's kind of cool. It opens up. See this? It opens up like a little window here, so I can actually just run my, I can run stuff inside the browser. But what I do in this other window here is I just run that smoke test. So if we go here and I say smoke test, we just do all those invocations of the service, and we can see they all worked. And then if I go to here, you can see this is the results of the prediction. And then here we actually have all the logging set up. So it's kind of a classic microservice, with the twist that this is actually a running computer vision model. And because it's using Rust and using the Actix web framework, it potentially could be incredibly good performance because Rust Actix is actually one of the fastest web frameworks in the world. It kind of goes back and forth, you know, which one's faster. The other part of this project is if we go to the Docker file, this is even if you don't use Rust, this is something I've been learning about recently, is that you can use this thing called Distrolist, and it makes like tiny containers. So it's like the smallest container you could possibly build. So in this particular scenario here, if we look at this, we say from Rust 1.67 as build. I do all this complicated stuff, like I download PyTorch, I set environmental variables, like I copy a model, you know, a pre-trained model inside of there, you know, I do a release, all this stuff. So that's all the like stuff you would normally do in a regular container. But this is where what I do is I copy all of this into this Distrolist container. And I've actually been able to build Distrolist Rust command line tools that are like 10 megabytes or 20 megabytes. Like just believe it or not, a container that's like 20 megabyte container using Distrolite. In this case, because it's computer vision and it's got all these libraries and everything, it's a little bit bigger. So if I type in Docker image ls, you can see here that it's actually 3 gig image, but that's tiny compared to regular PyTorch. Like PyTorch images could be like 10 gigs. So this is just incredibly small. And then what's nice is once you have it in a container, we know that like everything you can deploy with a container, you can deploy to EKS, you can deploy to App Runner, you can deploy to AWS Lambda, you can deploy. So that's one of the goals of this, was just to build a proof of concept that, yeah, you can use Rust, you can build, you know, binary based deploy, or you can use the Distrolist to actually package PyTorch with it. Because one of the tricky things about the computer vision libraries is you have to set things like libtorch path and shared libraries and all this. It's like kind of, you know, like some of the things are a little bit tricky. So if you use a container, it actually helps wrap it all together. So this is a little bit more of a complex project that I don't think is that conducive to like walking through the code, but I can shift to another set of repos that I have that are really simple projects.
Yeah, I think we need that, because not everyone here has background with PyTorch and so on. So it's like still really just trying to get a sort of a
Sure.
a feel for Rust.
Yeah. So if you want to go to this particular repo here, Rusty deploy, this is a good one if you just want to deploy a computer vision model and say, hey, I have a computer vision model. It's tested, right? It's reproducible. You can reproduce it. Now, the one that I'm going to show you that's a lot more like user-friendly here is this one, which is Rust. So I guess I should throw these in chat so we don't forget. So let's see here. So we got this one, which is the PyTorch one. And then the MLOps one is this one, which I have a lot of little teeny projects in. And so I would say what I'm going to do in this one is just walk through like a hello world, essentially. Like, so a good one that I like to write for hello world is Marco Polo, which is you have a function that accepts the word Marco, returns Polo, right? So this is definitely hello world stuff. So let's take a look at that. Yeah, that other project is more like level 10 difficulty. There is no more difficult project probably than that project. But let's start at level 1. So again, what's nice about this is because I have the pre-built environment that you should be able to just replicate. If you launch this code space, you should be able to replicate the majority of these projects. I don't think we'll have any problem at all. You can just CD into the directory, and there's a ton of them. In fact, I don't know why this is taking a second to wake up, but let's go back to this repo real quick, and as it's as it's waking up, I'll show you some of them. Let's go here. So the one that I'm about to show you is going to be this one, this Marco Polo. And this is a good structure. Let's just go. Okay, so it's back, but basically the structure is you have your code and source, you have maybe some tests here, you have a cargo file, and then I like to have a make file. Now, if you want to start a new project, this is probably the best way that let's say you know nothing about Rust and you have Rust. The first thing that I would recommend to do is actually, there's a tool called Rust Up. So if we go through here and we say Rust Up, it literally, in many scenarios, that's all you have to do is just copy this and just throw it into your browser and you'll have Rust. So that's amazing that you can just do that. It works well on OS 10, it works on Linux. So let's assume that you did that. You just copied Rust Up and you just threw it somewhere. The next thing that you should be able to do is create a new project. And so let me just show everybody how to do a new project. So let's just say, like, we'll call this cargo new Boston AWS. We'll just say Boston AWS, right? Anytime you create a new project, you use a tool called Cargo, and you say new, and what that'll do is it'll create a directory that you can actually CD into. Now, another option that you can do is you can say cargo init as well, and that'll just create the structure in your current working directory, and you can do like name, and you could call it something. I like to do a lot of like demo directories, so I typically say cargo new like this, and I just say again, you know, hello Boston, like that. And if we go ahead and we do that, you'll see that inside of Hello Boston, it actually already creates a hello world for you. So let's CD into there, Boston, and what it'll do is it'll create a main file. So this is more like let's go slow, right? Is that there's a function and it prints hello world, and so we can just change it and we can just say hello Boston. There you go. And now the question is, well, how do I build it? All that kind of stuff. You can just say cargo run, just like that. And if you say cargo run, it compiles it, builds it. That's it. So it's actually pretty straightforward. If you're not, when you get into a bigger project, there's lots of tricky stuff, but honestly, it's not that bad. Now, let me show you a little bit of stuff that might be come up with Copilot, because notice I have actually Copilot enabled right here. So one of the things that you could do is you could just say, like, you know, use Rust comments. You could say like, create a function that adds two numbers, right? And we could just say, okay, what are you going to do? There you go, right? And you can see, like, if you look at a function that adds two numbers, not too bad, right? It takes an A and a B. Here's their type, and then there's an implicit return. Now, we could, if we wanted to, you know, make it a little bit more gentle, I guess. We could say, you know, we could define a variable to store the result. So we could say let result equal A plus B, and then we could actually explicitly return the result as well. So this has, unlike Python, it actually has an explicit return, like Erlang has that as well, like an explicit return. So then now that we've got that, all we have to do is we could, if we wanted to, we could just say, like, you know, local results, or local variable, something like that. And we could say, it would change this around, right? I mean, the thing about Copilot is it's so smart. It kind of knows what you want to do. And now you have a couple different options. You could lint if you want. So you could say, you could basically do Clippy if you wanted to, or you can just do the same thing, just say cargo run, and it will try to compile it for you. And this is what happens typically, is when you first compile, you get angry. Like, you're like, oh, stop, you're doing all this stuff. And like, you get really upset about it. But once you start to get used to it, it's like, oh, okay. this is not that bad, is you just fix it. And it tells you exactly what to fix. So in this case, we say, oh, look, add a semicolon. Okay, sure. Unexpected token, local variable cannot find this. Oh, well, we didn't define it. So we need to say let local var here. And then not found in scope. I think we'll fix that. So I think all we have to, and even will tell you, look, the compiler is like Copilot. Like it tells you exactly what to do. So we just go again, cargo run. Here we go. Hello world 3. So to me, yeah.
So I just a couple of observations. I was going to ask you about the semicolon, because it seems like it's occasionally there, occasionally not, and I'm curious about the bang after println. And it's funny because I understand the whole compile time, because as a server side guy, the notion that Python or all the interpreted languages, the fact that I could get a syntax error at runtime in production months later always kind of wigged me out. And having said all that, it's like, okay, we're back to high ceremony.
Yeah.
Or at
Go
least
ahead.
medium
I was
ceremony.
just gonna say, because like I was coming from a language like TypeScript where I just leave off the semicolon because it doesn't really matter 99% of the time, right? But here actually it's kind of nice because you don't need to have the return keyword, right? If the last thing, and you can think of everything as like an expression, right? If statements are like expressions, you can set it equal to a variable. And so the last thing is usually what you want to return. So you just put that without a semicolon. If you actually want to return nothing, like the unit, and they call it in Rust, then you put a semicolon, the expression ends, and then the function ends, and it just returns nothing. Right. So it's weird at first, but it's kind of an elegant way to have less like characters.
Yeah, the code is fairly concise. I mean, you really can, build like very tiny code.
Mhm.
And then if you want to, yeah.
Sorry, he was also asking about the bang there. Like there's different kind of macros. Some are like the attribute macros with like the hash square brackets, but these, like, for the most part, you can just think of them as functions, right? Like in Rust, there's very strict rules about overloading things. So to make certain types of functions that take different arguments or whatever, you have to technically make a macro. So creating them is like a little bit different than just defining a function. But when you're invoking it, you can kind of think of it as just calling a function.
So println bang is a macro?
Yes.
Okay, that's actually kind of, I'm not opposed to that. It's just something to think.
And that's like the syntax of Clojure or some other languages that have macros, right?
Okay. Yeah, it's funny because I could chew on these 12 lines for a little bit, and I notice it in and if people want just to move on, just shout at me. But I'm also just like in line 9, it's let local var. It seems so that the typing is optional there.
No, it's not. I mean, I'm sorry. I think it's because in local var, we know that the typing is already here, right? So in this case, the typing is actually inherited from the original definition. So that's one thing that.
Okay, I quite like that actually.
So like it can get annoying because you're used to writing bad code. Like in that you start to try to coerce some type and you're like, this is ridiculous. And it's like, oh, well, actually, yeah, I shouldn't be doing this. Like, so if you were going to try to change it or something, you would have to explicitly declare a type, but it's passing through,
Right. So it seems like there's type inference here. So as you were saying, add has a signature where the return type is declared as an I32. And so therefore, implicitly, local var is an I32. And if you then tried to have another variable that was a float 64 and you try to assign local var to it, do you get a syntax error because you have a type, you have a conversion there that you didn't specify how to handle or something like that?
Yeah, it's very, very specific that like that's the thing that takes a little bit of getting used to, is that the compiler just whines about everything. But on the flip side, that your code, once it runs, I mean, it's probably going to work.
It reminds me of Scala. If you can get your Scala code to compile, you're done because it's going to be fine. But
so the pattern that I like to use, so that was just hello world. So the pattern that I like to use is more the command line tool pattern or microservice pattern like Lambdas, in that here's another one which is slightly more complex, but not much. Let's take a look at this one. So let's go up a directory here, and I'm going to go into Marco Polo. And if we go to this one, I have a lib and a main. So typically you want to put your logic into lib, and main is nothing. And so in this case, what I did is I built a function that is a Marco Polo function. And all it does is take a name, which is a string. And if it matches Marco, it returns back Polo. Otherwise, it returns back Marco again. Or we could even change it. We could just say like, who are you? Whatever we want to put right here. And then in terms of this, this is how I have been building command line tools. I think there's actually even a newer version of the parser, clap parser, but basically you create this initial syntax here, which has the version, who wrote it, an about message, which if to me feels not bad. Like it's not like horribly bad syntax. And then you create a struct that actually are the things that are happening inside, like if there's a subcommand. And then you have in this particular derived parser, you put in the subcommand that actually is the thing you want to do, and then you have the actual options here. In this case, it's a name, so I would have to run play and then name, and then all I have to do is then invoke it by basically referring to the name of my package here. So in this case, the reason I say Marco Polo is if we go to the cargo file, which is the project file, notice that this name is how I would refer to the library code. That's the only thing that's a little bit tricky sometimes to be aware of. And if we go back to this code, we just have to know that inside of my library here, I have something called Marco Polo. And so whoops, wrong main. So I have to actually say my package Marco Polo is actually using the function Marco Polo, which is in my library. I mean, I could call it something else to make it more clear, but to run it, pretty easy. You just do this. You just say cargo run, and again, it will compile. And the compile for something simple is not too bad. It's reason, and it says, look, no subcommand was used. Okay, well, how do we use a subcommand? We just do this. We do dash, and then you can just pass in stuff into the command line library. In this case, we say help, right? And you can see that, oh, look, I have a command called play, which is this one right here. And now if I do play and I do help, we can say what the usage is, and we see that it takes a name. So then I could just do, name, and we could just say Marco Polo. And if we say Bob or something like that, we can go ahead and do, who are you, right? So it's for building command line tools, it's not bad. And also show you this is that if you go into the target, it'll actually create inside of the debug, if you just do like a run, it actually will create a binary for you. And so we could actually just run the binary, the debug binary, if we want. We can just say Marco Polo and just do help. There you go. And it works. And we can just say play -- name Bob, right? There you go. And if you want to do a like a release, instead of doing cargo run, you just say cargo build -- release, and then it goes through and it builds a like an optimized binary that you can just give to somebody. So in my opinion, for building like lambdas, for building microservices, things like that, Rust is, I mean, the code is, it's not a lot of code to build stuff.
Yep. So Noah, it's thank you. It's at the top of the hour. I want to
Perfect.
just share a couple things. So I'm sharing the results of the survey. And I want to show you the what we're giving away for swag. And so this is the Boston Swag Store. Lovely mugs. So it's and I always don't have the mug with me at the meeting, so that's a drag. So here's what we're going to do. So the swag is based on a trivia. So I'm going to show you, let's just move the window. I'm going to show you a bunch of names, and eventually the way we do the trivia is you put the right answer in the chat window, but don't, so no yelling out, but let me set this up. Okay. So we have a bunch of names here. Okay. So we have Rust, which is a programming language named after corrosion. We have Cassandra, a data, and some of these are true and some of these are false. Cassandra, a database named after a Greek person doomed never to be believed. I Smell, a product that emitted odors based on the website you visited. GIMP, a photo editor that's a slur against disabled people. Burning Love Pouch, which is a fuzzy iPod case. And then Robitussin. So GNU stands for GNU's Not Unix. And so all of GNU's phrases were takeoffs on GNU, and GNU has conf files, or Unix has conf files. So GNU has Robitussin files. Let me just find my chat window again. And okay, so which one of those is false? Keep guessing. yeah, Rust is the false one. No winner so far. I'm going to give away a big hint. Might be a trick question. Yes, Tim, they are all true. They are all true. See, that's what you get when you make me do a trivia question that isn't about science fiction.
I want to know more about the ice. I want to know more about the ice smell. I'll have to look that up.
It was an actual device that would emit different odors based on what website you went to. Yes, I like that I've horrified people. I think this I don't know, was this a dad joke? I mean, it's
I remember seeing that when it came out and just thinking how stupid that was. And yeah, this is the first time I've thought about that in at least 10 years.
Right. So naming is just intriguing to me, and I will periodically bust Noah on the fact that Rust, it's a language based on corrosion. But I used to be a Cassandra DBA, and it's like, you've named a database after a character who was never believed. Just crazy making. So da, 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 da. Okay. Hold on one sec. We've got well, I'm not going to do the survey. So, well, actually, any more questions for no?
So I don't know if you explained Cargo. It looks like it's both a package manager and a build tool. Is that a
Yeah.
fair description?
Yeah, so Cargo is in fact very similar. I mean, it has some comparisons to like maybe Python pip and virtual env, or or Conda or something like that. The big difference is that, in my opinion, it's a lot more intuitive than those tools, because it has a formatter built into it, it has a linter built into it, it has a build tool built into it, it has a release tool built into it, and package management is built into it, and they're all actually pretty straightforward to use. And so yeah, and also when you do rust up, that one command, you get all of it. There's nothing else to do. You install rust up and you just type in cargo new and you're good to go.
And then if somebody was interested in going through a tutorial that's more than just a hello world, but kind of as Brian was saying earlier, gets you to think a little bit about the language and how to use the language and its design space. Can you recommend anything?
Yeah, I would say, I mean, so the repo that I shared, the Rust MLOps, is not all MLOps. There's actually a lot of like command line tools, AWS utilities. So I think some of those are probably good ones to just like see some examples of pretty small tools. Another one that I would recommend is probably, because a lot of you are maybe you're cloud type people like me, is that this book is pretty good. The command line Rust book, I would recommend it. And the repo that's available for the command, you just Google like O'Reilly command line Rust and you'll find the person's repo. But pretty good. I think that, because a lot of them are like Linux tools and things like that. So it just depends on how you learn. Like, I don't necessarily like the language tutorial type things because they're not really practical. Like, oh, what's a vector? And like, it's nice to look it up, but I don't really learn it. I would say the command line Rust is pretty good to really get into the weeds there. And then also a lot of the examples I've probably given in the Rust MLOps they're not all MLOps. They're like how to build an AWS Lambda, or how to build a deduplication tool, or or how to build a microservice. They're all like kind of things probably that a cloud type person would probably care about. So between those two things, I think that book and then the Rust command line tool book and repo, I think that's probably all you need.
And I'll invite people to, I posted in the chat a link to our after meeting survey. So I'd appreciate folks to go there. And I think that's what we have time for. Thank you. I feel like Rust is going to be on my path, and I feel that it's going to take me more than 60 minutes to learn it.
I honestly, if you just only build command line tools, you can learn it in like an evening, not even an evening. Like, I think if you just focus on only build a command line tool, you could learn it tonight, right? It just stay there for like 2 weeks. Just build really simple command line tools. Honestly, you can learn it in like a couple hours.
Okay, and bear in mind, folks, that Amazon is betting on this big time. Most of their new stuff is being written in Rust. A lot of their old stuff is being retro ported. and Code Whisperer, which is sort of their Copilot, which and I'm a big fan of Code Whisperer, which just went GA yesterday.
What was
Today.
this? Yeah.
Yeah, it was funny. They had delayed the announcement, but somebody in Europe didn't get the announcement, and so at some summit they pre-announced it a week ago, and that caused some to do. But it I believe is going to be supporting Rust. So
Really? Woo,
Yeah.
I love this.
yeah, and I have some other stuff under NDA. I can't tell you, but Rust is coming down the pike. So we have lots more coming down the pike in the next few months. Maybe the CloudFormation Terraform CDK cage match, and a bunch of other things. So stay tuned, stay safe, and have a good evening.
Talk to y'all later.
All right.
Take care.
Yeah.
Bye.
So-
Thank you.